Hi everyone and welcome into this new video. In this video we will continue with Python programming. In the previous video I showed how to generate HTTP traffic using the Python programming language and the request library. In this video instead we will do web scraping with Python. So we will talk about what is exactly web scraping and how we can do it with Python. As always, we will have an installation phase where we install all the libraries, which are two this time: a request library for making HTTP requests and beautifulSoup library for performing web scraping. And then I will show practical example, one in which we will extract all the links from my blog, so blog.leonardodamiano.xyz, and another in which we will parse the SQL injection output taken from the DEM vulnerable web application. And this is useful when you have a lot of data that you want to parse. We will show how you can approach such problem with Python. So, as always, I hope the video is enjoyable, you find some use for it. If so, please leave some feedback, subscribe to the channel, spread the channel with like-minded people and help me grow, show me your support, and I will keep creating content like this. So, as we did before, let's talk about installation. So for the installation, once again, we will create a Python virtual environment. So with Python 3-m VM. So the first VM is to use the module for the creation of the virtual environment. The second VM is for the name of the environment, which I just like to call it VM because it's simple. Then we activate the environment with .vm bin activate. Notice now the prompt has changed. This means that the virtual environment has been activated. So now we can install all the dependencies. These are the request library and the beautifulSoup 4 library. So there are many different libraries for performing web scraping. beautifulSoup is one of them. Once we have all the dependencies, we can save them with pip3 freeze and then we say requirements.txt. So the idea is that in your version control system, you will just check in this requirements.txt, and next time you have to install the dependencies, you can do pip3 install-r requirements.txt, which is much simpler to do instead of remembering exactly what are all the names of the libraries. So this is for the installation. Also notice that in the requirements we have the version of the libraries. Maybe you want to pin them exactly so that this code will work with this specific library. So we can start with the first example. So we can say essentially links.py. So this first example, as always, I put the shebang and then I put the guard on main. So this is typical setup that I have. So this thing. And then we have this function, extract links from blog, which we will implement. So the objective of this example is to implement this function. Now, what do I mean by saying extract links from blog? Let's say that you are navigating a web page. So for example, this is my blog, blog.leonardodamiano.xyz. Here I have various sections. This is the technical section. And here I have a bunch of different posts. They are not that many. They go from 2020 to 2024. Now, suppose that I had thousands of blog posts, which is not the case, but just assume, like for describing the scenario, suppose that I had so many of them, and I wanted a way to just grab the link to each post, the name of each post, and the publication date. Now, the idea is that for the way that the web was defined and how it works essentially, is that the browser uses HTTP to communicate with the web server. In this case, it is my web server. But then the content itself that is displayed by the browser, the content that we are seeing right now, is HTML. So this is an HTML page. Now there are different ways of observing the HTML structure of a document. For example, we can do right-click, view page source, and this gives us the static HTML that is returned by the server. So notice I have a bunch of tags, I have lt-block-tech, and here I have all the different links, and then here I have some support for Majax. So essentially that's the idea. Also we can do, so we go back to the original page, we can do Ctrl-Alt-I to open the DevTools, and here I have a different view of the page. Now the difference between view source code and the DevTools view is that the DevTools view is based on the DOM. Now, DOM stands for Document Object Model, and essentially it is the dynamic rendering of the HTML document by the JavaScript code. So the idea is that the server gives the browser a static HTML at the start. And this is the HTML that we can see with tools such as Burp. So here, when I went to the blog, for example, this one, this get blog, here it says move permanently, and this is the get the OK. Now, this is the static HTML that is given by the server to the browser. Now, anytime there is some JavaScript, for example, script source dark mode switch mean JS. So every time there is a JavaScript, that JavaScript could, in practice, change the structure of the document. And so the document could change when the JavaScript loads. So in the dev tool, we see the final structure of the document. We can sort of think of it as the live dynamic document that is created by the JavaScript, while if you do view source code, view page source, we see the initial static version. This is why, for example, if you open a single page application written in React, when you do view page source or view tools, you will see two different representations, because in the view page source, in a single page application, you will just see the loading, the initial loading of the JavaScript. All the code, all the logic is encoded into the JavaScript. Now, in this case, for my blog, it's a really simple blog, so there's really not much to say, which means that we can just base ourselves on the static HTML that is returned by the web server. Now, this is important, is an important distinction to make, which is why I'm making it. Why? Because if we are just interested in a static version, we can use the request library to handle it, to load it, to request it, and to obtain it. So we can just do import request, then we define the URL of interest. In this case, it's my blog, so it's this one. So this is the URL, protocol https blog.narodamia.xyz/text/. We make the request, and that's it. If we now print r.text from here, we have the exact same HTML that we are interested in. If I just do this, all this HTML, notice all these archive links, notice all of this. So we have a bunch of archive links, and you see this article tag is the same tag that we see when we open the view page source, because my blog does not use much JavaScript and does not use JavaScript to change the content of the site itself. So this is the first step, and this is for the request library, which I already introduced in the previous video. Now comes the web scraping part, because the idea of the request library is to obtain the HTML itself. Web scraping, however, has also to do with the entering into the HTML data and extracting the data of interest. So to do that, we will need the new library, which is from BS4 import beautifulSoup. So we want to import this beautifulSoup object. How do we use it? Well, we create a soup object, soup equal beautifulSoup. So let's do beautifulSoup. We put r.text and then we say html.parser. So the first thing is to make HTTP request to obtain the HTML data. The second request is parse the HTML data into a soup object. So why do we need to do this parsing? Because at this point, the HTML data is just text. It's the way we view it here. We cannot, there is no structured way to access this data. To have this structured way, we need to use a parser. We need to use a beautifulSoup or another library that is able to parse the data into a structure that we can then access. And typically, these are so-called tree structures in computer science, because they resemble objects such as these, where you have the root of the document here, and then you have, for example, the head, then you have the body, and everything that is inside the body is under this node, everything that is inside the head is under this node. And HTML is particularly simple to parse like that, because if you notice, you have the HTML tag, which encloses the entire document, so it's sort of like the root. Then you have the head, then you have the body, then inside the head you have the various meta tags. So they sort of introduce naturally this HTML is the root, then we find the head, then we have the body. Inside the head, we have a bunch of meta, so like meta 1, meta 2, meta 3. Then we have the title also inside the head. Inside the body, we have the div. Inside the div, we have the input, and so on and so forth. So we have a tree structure, and beautifulSoup allows us to navigate that tree structure in order to extract the element of interest. How do we do that? We have a bunch of methods. The most simple one is, okay, let's analyze a little bit the structure of our page. So the cool thing is that the way that the HTML is generated is really simple, because we have for each article an article element. So we have a starting article tag, HTML tag, we have a closing article tag, and inside this tag we have the article element, which contains the link for the article, the name of the article, and the publishing date, the date that the article was published in. So we have everything we need in this article. Now, how do we extract all articles from the beautifulSoup object? It's really simple. We do soup.findAll, find all elements that are called article. So find all the elements that are defined by the article tag, and I'm gonna call them articles here, and I can also print this thing. I can also print this list. It's gonna give us a list of objects. So here I'm gonna zoom out. I'm gonna call this thing, and notice here I have a list of various elements, where each element essentially is an article element. It's like it contains the entire article HTML stuff. So this is the first, then there is a comma here, then there is the second, comma here, third, comma here, and so on and so forth. So the idea is to iterate over all those articles. Perfect. Now, how do we do that? Well, the idea is that now we want to obtain our data. So we define a list, which will return at the end. So we will return data, or maybe something else. So first of all, here is now we can query the document and extract the parts we are interested in. Okay, data. So for article in articles, within the article, let's remember the structure. So I'm gonna bring this into the code. This is very useful when you want to do web scraping. You just take the piece of HTML you're interested in and you bring it into your editor, you comment it out. So we want publication date, we want something for the publication date, we want something for the link, and we want something for the title. Once we have these three pieces of data, we can just append it to the list data. We're going to append a dictionary, which is going to have title with title. It's going to have link with link, and it's going to have date with publication date. And once we have all this data, we can just print it. Now there are many ways to print it. So let's say that I just print it like this. Of course, now it's empty, but the idea is that we will fill it with the data of interest. But notice that this is pretty ugly. So one thing that we can do is we can go up in the code, we can import the JSON library. This is built in Python, so we do not need to install any third-party dependencies, while request and beautifulSoup had to be installed like externally. JSON is internally in Python, so you can just say import JSON and it works as follows. It's pretty easy. So we're gonna do this. We're gonna do JSON dumps data, and then we're gonna put an indent 2. So the idea is that this is gonna load the dictionary, it's gonna print a JSON string representing the same dictionary, but it's gonna indent the output. So it's gonna be more readable. So this is just for readability's sake. It's a very useful trick. So you can just do this and notice now it's much more readable. Now, of course, the data is all empty, right? How many articles do we have? We can just print. Let's just print, like, for example, we can do print len the articles. How many technical articles have I written? Not that many anyways, but they are 29. So 29 articles, not that many, but we want to extract the data for them. Think if there were like hundreds or thousands, manually would be a disaster to do it. So we want to use data scraping technique, like web scraping techniques. Now, let's go back to our HTML. How do we extract the data of interest? So for the publication date, as you can see here, the date is included in the time element within the article. So we can do as follows. We can do article.findTime. this is gonna find the first instance of an element time within the element article. So before we said find all, so it's gonna return us a list of all the elements. In this case, since it's a singular find, it's just gonna find the first. In this case, the first is what we need. However, notice that we don't want the entire element. We just want the text inside the element. So we can do .text to extract the internal content of the element, which in this case is just text. So we do that. And notice if something changed. Let's see if something changed. Notice that now we obtain the publication date of all the posts. And the last one was 2024-07-22. So that's good. Now for the title, it's similar if you think about it. Because the title, we have to go into, so we have a header, we have an A, and then within the A, we have the text of interest. So what we do? We do article.find A, and then we do text. So this means that find will find also nested elements that match our description, because here A is nested within header, but it still finds it. Indeed, if we now execute it, we're gonna get the name, the title, and the publication date. So the last thing we need is the link. For the link, notice that the link is included in the href attribute of the element A, of the anchor, of the HTML anchor. So how do we extract it? Once we have the HTML anchor, this find A, we can just do, it's a dictionary for beautifulSoup, so we can just access the property href. And now we also have the link. And if you notice this now, look at this. We have all the data of interest. For example, let's see this Android emulation setup. So we're gonna go here, just check if we make sure it works right, and boom, we have our article. Let's put another one, the importance of RSS. We're gonna do here, boom, let's see. Once again, we have the correct article. So it seems to work. The cool thing is that once we have this data, we can put into data.json, and then essentially we can process it however we like. That's the essence of data scraping, and specifically web scraping. We start by making HTTP request, then we obtain the HTML data we're interested in, and then we parse it and we scrape it. We extract only the elements of interest, and this allows us to go from this output, which contains a lot of data, metadata, and things like that, which are not really useful to us, to this output, which contains only the data we are interested in. So this is the essence of web scraping. Now, to finish off the video, I want to bring a more concrete example. And in particular, we will use once again the then vulnerable web application. So consider, let's log in into the application and consider the SQL injection module. So here, of course, we have an SQL injection, which allows us to obtain all the username and passwords for the various users. Now, in the case of the application, there are not really that many users. So we could manually parse all this data, just extract the name and the surname, the password, the hash password, and we would be good. But imagine for a moment if the result that it returned was like 1,000 rows, 100,000 rows. Now, how would we scrape that data? In this case, data scraping techniques are useful, and especially those that are automated using tools like Python. So I want to showcase how can we extract automatically this data. So that's the idea for the second example. So we're gonna create sqli.py, so Python. As always, I have the shebang. As always, I have the main guard that I use just to make sure that the code is executed only when we want to execute it. And the main function we will implement is scrape data SQLi low. So since we are using, of course, the data scraping technique, we will have request, we will have beautifulSoup, and also we will have JSON for the trick with the indent that I showed. Here I have a bunch of global variables, so my list of proxies, my dictionary of proxies, I should say. As always, localhost 8080, both in HTTP and HTTPS. So this is just simple. And then we will put the php-sesd, which is the session cookie that is used by the application to authenticate the user. So in this case, we can just grab it from Burp Suite. I talked about this in the previous video. So that's the idea. Now, how do we handle this? So first of all, let's like declare the global variables. Then, of course, we need to make the request, the HTTP request. So we get the endpoint of interest, which is this one. So we say HTTP /localhost, and then we do /this thing. So this is the URL. Then we have our custom parameters, and then we have our custom headers. Now, for the custom headers, we just want the cookie to authenticate. So here we have a format string, php_sid equal to php_sid, the global variable. So this one, but of course it has to be caps. And then we have security equals slow, perfect. So this is just all the custom headers. For the custom parameters, of course, this parameter must contain the SQL injection input, the payload. And we have two parameters, ID and submit. Submit is always the same. Submit its value is always submit. And then ID instead is the payload that allows us to perform the SQL injection attack. So how to extract this? Here is the URL encoded version. Here with the inspector, we can just copy the original version. Decode it here, and we put it here. Because the library will automatically URL encode it, because that's the idea. So this is the payload, we are good, and now we can make the request. So we make the request, request.get, we do URL, headers equal custom headers, params equal custom params, and then proxies equal proxies. And I've made an entire video on how to use the request library, so if you don't know about that, just go watch the previous video on Python programming. At this point, we've made our request, we have our HTML output, we can even check it, look, r.txt. So I'm gonna zoom out, I'm gonna do sql.py. So here it says, look, I have a vulnerability here, let's see why, because there is a space here, I think. Okay, I forgot a space at the end of the payload. And notice now that we get all the data. It is all formatted into this pre tag, so very difficult to read. So as I showed in the blogging example, at this point we have the text and we need to create a soup object. So we do soup, beautifulSoup, we do r.text and html.parser. And then at this point we have our user list which we're gonna create. So at the end, here is gonna do parse data into users, and then we can just print it out with the trick json.dumps users indent.1, indent.2, which is the one that I showed previously. So that's the idea. Now, how is the data formatted? At this point, we can just take out this chunk of data, which contains all the output of the SQL injection, and we can analyze its structure in order to properly parse it. So actually, let's not put it here. Let's create a new buffer. I'm gonna call it TMP. I'm gonna do HTML mode. And so I'm gonna do it like this. So notice that first of all, for every user, we have a pre-element. So we have pre here, and that's it. So we have 6 users, we have 6 different pre-elements. So this will bring us essentially to the code, to the correct code, because the idea is that, okay, we're gonna find all the pre-elements. So we're gonna do for pre in soup.find all pre. So we have the single pre, which represents a single output. So notice, however, that the first output we don't really care, because in the first output there's no hash. So we can skip it, and we can skip it with this syntax, with this slice. This is the Python for slice syntax. So we say, give me everything but the first element. Don't consider the first element, only second onwards. So that's good. Now at this point, we want the text of this pre-element. So we can do strpre to obtain the text representation. And then we need to extract 2 elements, the username and the hash of the password. Now to extract both of those elements, we can abstract away a function. So we can say user extract element text, password extract element text, and then we can define this function extract element. Of course, we do not need to just give the text to this function, because otherwise, how can we first extract the name and then the hash password? So the idea here is to differentiate between the 2 elements by using a start label and an end label. So we are start label, end label. And the start label here, for example, for the name, is everything that happens before the name. So this thing. So essentially, we have this first name, semicolon, space. This is gonna be the start label. while the end label is what happens right after, so this BR tag. For the password is similar, but it's actually surname is the start label, and then the end label is the pre tag. So this is the pre tag. So we're going to define this function. Once we have all this data, of course, we can just use user.append as before, single dictionary with user, password, password. Pretty simple. So that's the idea. And of course, we have to define this extract element. So this extract element works with the textual representation extracted using beautifulSoup. So how do we do it? Well, the idea is that we start from the string, right? So we want to find the occurrence of the string, the occurrence of start label within the string. So we do text.find start label. Now this is actually going to give us a numerical index. It's going to say, look, if you're interested in first name, semicolon, and space, this is going to be at index 66 or at index 67, whatever, like a specific number. So this is what we extract first. Then we want to extract the end label. But we have to be careful about this. Why? Because this end label has to be extracted after the start label, not before, after the occurrence of the start label. Why? Consider this BR happens many times in the string, happens 2 times in the string, but we are interested in the one that happens after the first name. So how do we do this? Well, the idea is that we start from the text after the start label, so we can slice it like this with the I in the initial index of the slice. Then we do find end label and we return this to J. And then what we have is, we essentially have all we need at this point. Why? Because we can do as follows. We can return text. We're going to return something taken from text. So here we have essentially to define a slice. And after we define the text, we can just strip it. So we can just do strip. So whatever we return, we're going to strip. And this is going to remove the white spaces at the beginning and at the end of the string. So the initial index here is taken by taking I, which is the start of the start label, but we want to skip all the length of the start label because we're not really interested in the start label. Like we started first name, but we actually want to skip all these to obtain directly admin, right? So this is it. And then at the end, we want to do I plus J. Why? Because J, remember, starts at I. So it's like an offset. It's like J is offset with respect to I. So this means that if J is like 2, this 2 has to be applied after I. So we have to do I plus J. So this is how it works. And with this, essentially, we're able to extract specific elements of the string. And if we run this code, let's see what happens. See what happens, look at this. We do not get the user for some reason. So this has to be fixed. We do not get the user. Why? Extract element text, extract element text. So I have first name, surname, user, okay. This seems suspicious. Let's see if we extract it from here. So if we print it, we do not, we literally do not get it. This is probably because, okay, let's see. So I was trying to debug the reason, the mistake why it didn't work. So I just printed everything that came after start label. And here I get admin, and then I get BR, but then I notice that this BR that I get is different from the BR in the original code. The BR in the original code had a space between the R and the slash, but this one does not. So here at the end label, I have to use a BR without the space. And the reason for this is that beautifulSoup must normalize the data so that it removes this useless white space. Now at this point, I can remove this print, and I'm pretty sure it's gonna work properly. Indeed, notice we're able to extract the user and the password. So this function is just simple string manipulation in Python to extract a string between a start label and an end label, and everything else is a bit of the request library to get the HTML data, and then a bit of beautifulSoup to parse the HTML data. But in terms of parsing here, we are not doing anything too complex. And the output of this is that now we have a structured way to access the data, which is much better than just going to the browser and copy pasting stuff. This can be useful when you're doing bug bounty, when you want to fill out a report when you want to just show to a company that you're able to structure the data obtained by an exploit and stuff like that. It's useful for other reasons that go beyond computer security and cybersecurity. It's just a useful technique to know. And with this, the video ends. I showed the basic idea behind web scraping, how it works, why it's useful, and why you should learn about it. And we showed 2 different libraries, one for making HTTP requests, I've made a video about that previously, and one for working with HTML data, beautifulSoup, with the HTML.parser. So I hope the video was enjoyable. I hope you got something out of it. If you did, please leave some feedback, help me grow, subscribe to the channel, and share with like-minded people, and to the next video.